From page 216, 5.2, check your understanding. The problem is, a skydiver opens his parachute and shortly thereafter, he is moving at constant velocity. Letter A, what forces are acting on him? Letter B, which force is bigger? So, mano siya nga atong drawing, mano yung parachute, then ang skydiver. So, the force of the air resistance with parachute acts upward. Padong upward ang air resistance nga with parachute. Padong siya upward. Then, ang weight sa skydiver nag-act downward, padong sa ubos. Then, letter A. From the question, what forces are acting on him? The forces are acting on him is the force of the air resistance with parachute and his weight. From the questions letter B, which force is bigger? So, the force are equal in magnitude because there is terminal velocity of core, which is the net force acting on the body becomes zero, and due to the zero net force, the net acceleration becomes zero and the object fall down with a constant velocity. From page 223, 5.4, check your understanding. The problem is a 550 kilograms sports car collides with a 2,200 kilograms truck, and during the collision, the net force on each vehicle is the force exerted by the other. If the magnitude of the truck's acceleration is 10 meter per second squared, what is the magnitude of the sports car's acceleration? So, man siya ang drawing, mani ang sports car, then truck. Nagtimbang ang truck og 2,200 kilograms, then ang sports car 550 kilograms. The given is 550 kilograms, which is sa sports car, 2,200 kilograms sa truck, then ang acceleration sa truck is 10 meter per second square. Required sports car acceleration. For solution, using Newton's second law of motion formula, which is F net equals ma. Substitute mass, then acceleration, then multiply. The F net here is 2.2 times 10 to the power of 4. Muna siya ang F net sa truck. To find sports car acceleration, using gapon sa Newton's second law of motion formula, which is F net equals ma. Diba ang F net nato na iyang value is 2.2 times 10 to the power of 4. Substitute. Then ma, ang mass sa sports car, which is 550 kilogram times a. Then para mabilin ang a dire, so divide both sides by 550, cancel. So nabilin dire sa right side is letter A, and then divide dire sa left side, 2.2 times 10 to the power of 4 divided by 550. So the answer is 40 meter per second squared. Mao na siya ang acceleration of sports cars acceleration. Mao na siya. 5.5, check your understanding, page 266. A car has forces acting on it as shown below. The mass of the car is 1,000 kilograms. The road is slick, so friction can be ignored. Letter A, what is the net force on the car? Letter B, what is the acceleration of the car? So, maning drawing. Then the given is F1 equals 450 Newton, F2 equals 380 Newton, 30 degrees, and then 10 degrees. Solution. For Fx equals 450 times sine 30 degrees minus 380 times sine 10 degrees. So Fx equals 159 Newton. For Fy equals 450 times cosine 30 degrees plus 380 times cosine 10 degrees. So Fy equals 764 Newton. For net force, Fx I plus Fy j, so the net force here equals 159 Newton I plus 764 Newton j. X component of acceleration, E of x equals Fx all over m. Ex equals 159, and then for m is 1000. So the E of x here equals 0.159 meter per second squared. For y component of acceleration, Ey equals Fy over m. Ey equals 764 1 over 1000. So Ey equals 0.764 meter per second squared. For net acceleration equals Ey I plus Ey j. Net acceleration equals 0.159 meter per second square I plus 0.764 meter per second square j. This is the final answer. From page 258, number 51, letter A, what net external force is exerted on a 1,100 kilograms artillery at 2.40 times 10 to the power of 4 meter per second squared? What is the magnitude of the force exerted on the ship by the artillery shell, and why? The given here, mass equals 1,100 kilograms. Then acceleration equals 2.4 times 10 to the power of 4 meter per second square. Then for solution, using Newton's second law of motion formula, which is F net equals ma. Then substitute ma, m 1,100 kilograms, acceleration 2.4 times 10 to the power of 4 meter per second square. So the answer for letter A is F net equals 2.64 times 10 raised to the power of 7 newtons. So sa letter B, question, what is the magnitude of the force exerted on the ship by the artillery shell, and why? So if the artillery shell is fired from a battleship and it has a force of positive, sa kani siya positive, so the opposite force would be now the magnitude of the force exerted on the ship by artillery shell, that should simply become negative 2.64 times 10 raised to the power of 7 Newton.